Okay, welcome back. So we're doing another lunchtime video for the JNCIE-SP. A few timeline things to take note of. Right now, September 16th, if we were in, I've called it World A. We're in World B right now. But in World A, I would be traveling to California and taking the exam. If not today, sometime either this week or last week. So that's just interesting to be aware of. I feel right now I'm not prepared to do that. I've just got too much to learn about MPLS and layer 3 VPNs and stuff. QoS I haven't even gotten to. So hopefully it turns out to be kind of a hopefully I can have a better chance of passing this exam now that we're in World B and I'm doing these videos a bit more consistently and in a bit different format than I had planned. Initially I had planned to just be in the office during my lunch and just work using the study space I had available to me in the office. So with the air conditioning blasting in my face and a TV on. And I mean, I guess. So let me put it this way. Well, you know, in fact, okay. Let me do this. I'm just gonna try to refocus here. I just don't think it's worth really thinking about World A all that much because World A really doesn't exist anymore. We're all about World B. And plus, there's good news. World B might have some different kinds of opportunities than World A had, so I want to make sure I'm focusing my efforts appropriately to take advantage of those opportunities. So, World B I might have a better opportunity to actually pass the exam. World A, I'd have a better opportunity to get rewarded for passing the exam, but I think I would have worse of an opportunity to actually pass it. So let's not think that much about World A and focus only on World B and do the best I possibly can to pass this exam. Okay, so we've got a brand new subtopic. We're no longer learning about administrative. We're no longer learning about traffic engineering. We're learning about high availability techniques. The first thing we'll learn about in regards to that is FRR. So I don't even know what that stands for. This is going to be all new for me. So let's create the title. Okay, so it's not traffic engineering now, it's going to be high availability techniques. And it's no longer, the last topic we did was ERO. We looked at we figured out what ERO was. It's a manual label switch path statement. It requires RSVP. So there's going to be two lists associated with every LSP. One list is all of the subnets that the LSP has to traverse through. So on the first link, you're going to see every subnet, but as it traverses through the LSP, it's going to remove the ones that it came from. So on the last link, you'll just see one subnet. In addition to that list, it's going to have another one that I believe this one's called the route record object, which just has all of the subnets that it actually went through. It's kind of like, so it's kind of like the map and then the memory you have of actually traveling. You're really gonna think more clearly about the road you're on instead of the road you went through. Kind of think of it in that way, kind of like a road trip. You're really more concerned about the next destination you're going through. You're really not thinking that much about. So if I'm driving from Chicago to LA, and I have to pass through Denver, before I've passed through Denver, I'm really thinking about Denver. But then afterwards, I'm looking at the instructions, all that, the directions, all that for LA, and I no longer have the map out, and I'm looking at the map to get to Denver, but the map still has information to get to Denver. I just no longer need to look at it. So that's the difference between those two lists, and I'll show that one more time just because it's a new concept for me, and I think I learned it pretty well. So we're just gonna make sure I get the naming correct for that. Now I think explicit route object is, in addition to the name of the configuration, you can call it that. But I think it's defined also as that list where you're essentially using the map. So you're traveling through, you're using the map. That's called an explicit route object. You're only concerned about where you haven't yet gone to, and where you have gone to, you don't even need that on the list. But then there's also the route record object, which is more like your map, even though you're not going to be using the part of the map that you've already traveled through. It's still going to be recorded in the map. Now there is something interesting that does happen as well. When you have a ERO, as it's called, I looked it up, with links you have not traversed through yet, sometimes the ERO will list one side of the link or one IP in the link. So if it's a /30 and your subnet is .0, sometimes the ERO will say that you're going to traverse through .1, but if you actually used .2 instead of .1, your RRO will be changed to show that. So when you first start and it hasn't done anything yet, you'll see the ERO and the RRO with all .1s. But then as you move on, you'll see the ERO deduct entries in its list until it has just one entry left, and then you'll see the RRO rewrite its list so that it shows what actually happened. It traveled using the .2s, not the .1s. Okay, so let's take a look at that and then move on to the next topic as soon as possible. Okay, so we're going to do a show MPLS LSP extensive. We don't need to give it a name because there's only one, but in the test, where I'm sure there's going to be lots of LSPs and they're going to ask questions about specific LSPs, you can just use the name knob and then specify the name of the LSP. Okay, by here we can see our two lists, the ERO and then the RRO. So this is everything it's where it actually has traveled through, and this is where it's going to travel through next. It's possible to see that with show RSVP session as well. Yeah, so explicit route, yep, so it's the ERO, explicit route object, and then the record route object, the RRO. I kind of like the output a little bit better in the show RSVP command because it's more clear that there's actually 4 routers in the topology because you get this extra self. So I just think this is a little bit clearer. Okay, so let's look at the other 3, and we can see that explicit route object list decrement. Okay, so yep, we saw a decrement. There's only 2 entries now. We can also, yep, so we can also see that it thought it would traverse over .2, but it updated it and it actually traversed over .1. But here it doesn't even record at all because it's not record that at all because it's not concerned about what happened. It's concerned about what will happen. Whereas the record route object is concerned about what happened, but it also includes information about what will happen. Okay, so now that we've only got one link to go through, same thing, and we can see just like before where it used .1, even though it thought it was going to use .2, same thing happens. So all it does is just updates that record route object. Okay, so let's check it on the last one. I don't think I did that last time, but we'll see what that looks like. Okay, so I guess this is kind of what I expected. So we no longer have a explicit route object because we no longer need to go anywhere. We're done. We're here. It's the very last entry in the record route object. So we can see just like the other one, we thought we were going to use .2, but we ended up using .1. But at this point, a ERO is no longer even required, so we don't even have one. We only have a RRO. Okay, so let's move on to the next topic. Okay, so we won't need this open anymore. We're just going to need, yep, we're just going to need this. Oh, and this is going to be the, oops. Let me close that and just make sure I'm on the right one. So these are all marked done. Okay, this one's not done. It's a HighAvailability Techniques, FRR. Hopefully I got everything right. Oh, I didn't update the second part. Okay, so we've got HighAvailability Techniques, FRR. So let's learn all about FRR using the classic method. I think the tags are going to be fine. Yeah, let's just leave the tags the way they are and then use the tools that I'll have during the test to learn about FRR. Now, one thing we did learn is that those matches are case insensitive, so it didn't find anything for lowercase letters, but even if I use uppercase letters, it still won't find anything. I might have put FRR instead of FFR. Let's see what it's meant to be. Okay, so it is meant to be FRR, not FFR, so I did use the acronym correctly. Let's search for high, because maybe we'll find something on high availability. Okay, so I don't see anything like that. So I'm not sure, maybe the F stands for frame. So is there anything under MPLS that's like FRR? So I don't see any information for MPLS when I look for frame. Yep, and unfortunately there's no O. So let's just try, because I know this is something for MPLS, so let's just try looking at MPLS. Now we do have information on load balancing, so that actually sounds like it could be a high availability technique. So I think I'll look at that one. Oh, you know what? I bet you it's fast reroute. Okay, so it's short enough. Let's read about it. I'm pretty sure it's fast reroutes. Fast reroute provides a mechanism for automatically rerouting traffic on an LSP if a node or link in an LSP fails, thus reducing the loss of packets traveling over the LSP. To configure fast reroutes on an LSP, include the fast reroute statement on the ingress router. You can include the statement at the following hierarchy levels. You do not need to configure a fast reroute on the LSP's transit and egress routers. Once fast reroute is enabled, the ingress router signals all the downstream routers that fast reroute is enabled on the LSP, and each downstream router does its best to set up detours for the LSP. If a downstream router does not support fast reroute, it ignores the request to set up detours and continues to support the LSP. A router that does not support fast reroute will cause some of the detours to fail, but otherwise has no impact on the LSP. Note: to enable PFE fast reroute, configure a routing policy statement with the load balance per packet statement at the edit policy options policy statement policy name then hierarchy level on each of the routers where traffic might be rerouted. See also configuring load balancing across RSVP LSPs. By default, no bandwidth is reserved for the rerouted path. To allocate bandwidth for the rerouted path, include either the bandwidth statement or the bandwidth percent statement. You can only include one of these statements at a time. If you do not include either the bandwidth statement or the bandwidth percent statement, the default setting is to not reserve bandwidth for the detour path. When you include the bandwidth statement, you can specify the specific amount. Ah, shoot, I'm out of water. I'm gonna go get some. There's something in my throat. I'll be back. All right, I am back. So by default, no bandwidth is reserved for the rerouted path. To allocate bandwidth for the rerouted path, include either the bandwidth statement or the bandwidth percent statement. You can only include one of these statements at a time. If you do not include either the bandwidth statement or the bandwidth percent statement, the default setting is to not reserve bandwidth for the detour path. When you include the bandwidth statement, you can specify the specific amount of bandwidth in bits per second, BPS, you want to reserve for the detour path. The bandwidth does not need to be identical to that allocated for the LSP. When you specify a bandwidth percent using the bandwidth percent statement, the detour path bandwidth is computed by multiplying the bandwidth percent by the bandwidth configured for the main traffic engineered LSP. For information on how to configure the bandwidth for a traffic engineered LSP, C. Configuring LSPs for diff serve aware traffic engineering. Hop limit constraints define how many more routers a detour is allowed to traverse compared with the LSP itself. By default, the hop limit is set to 6. For example, if an LSP traverses 4 routers, any detour for the LSP can be up to 10, that is 4 plus 6 router hops, including the ingress and egress routers. Oops, I'm sorry, I accidentally forgot to unpause when I came back from my water break. But a lot of what I did was just nothing. Well, I actually did do some substantial things. I tried to set up the link coloration again, and then have it switch over to the other link automatically by enabling fast reroute. I thought that's the missing piece of the puzzle. That didn't work. I unfortunately didn't get any of that on camera. But really, the bulk of what I did was just compiling the resources I'll be using to study later. So I'm going to take another break. When I come back, I'll remember to unpause the video, and then the real content, especially as is relevant to FRR or fast rerouting, will be coming soon. All right, welcome back. So I've got the recording running for sure. This is going to be a shorter video, but I actually did, it probably would have been a 45-50 minute video if I had not forgotten to start recording. So unfortunately, what you'll see is a lot of reading, but even though I did do some hands-on. Okay, but yeah, let's just start by reading the OSPF problem overview. Problem description: incorrect configuration is a common mistake when trying to establish protection for an MPLS LSP. Protection with either fast reroute or link protection requires a per packet load balance policy exported at the edit running options forwarding table hierarchy level. Correctly configured protection for an MPLS LSP results in 2 next hop forwarding table entries per destination, either an incoming MPLS label or an IP destination. Figure 1 illustrates a network topology with link protection and load balancing enabled to ensure that routes are correctly placed into the forwarding table. Okay, yeah, I think this is what I did wrong. I didn't include the, shoot, they're not going to give the configuration that I was missing. Yeah, so I know what the problem is. I didn't have the policy applied here, the per packet load balance policy, but unfortunately I forget how to write that. That's probably not a good thing because I'm going to need to know how to do that during the exam. So you know what? Let's try to figure that out. Let's use the remaining 4 or 5 minutes to just, because I know exactly what they're talking about. I've done it, I remember it, I know what it does. I just don't remember the configuration exactly, so I'm going to be experiencing that a lot during the test, I'm sure. So to just give up is clearly not a good strategy, especially when I have such a great tool as Help Apropos. Okay, so we're gonna do pipe match, and then we'll do load dash balance. Okay, so I think it's gonna be one of these. Let's take a look. So here it is. Oh, no, I don't think that's gonna be it. Let's take a look again. So it would be under routing options forwarding table. Now this is forwarding options. So yep, that's not going to be it. Perfect. Yep, so here it is, the answer. It basically gave me the answer key right here. So let's do that, and then we'll try the coloration again, and we'll try fast reroute, and hopefully I'll get the result that I was expecting. Because the reason I did not have a route to the destination is because it just lost the ability to look at the link at the link, the only link it could look at. Like it didn't have the ability to look at that other side because that ability was not set up. So statement, we're going to say per packet load balance. Oops. Oh, it's going to be policy options, policy statements. Okay, and let's, okay, so from okay, I guess we don't need to have any match conditions. We can just, I think if we leave it blank, it'll apply to everything. So let's do that. All right, so the next part is going to be to call it. So we call it at the forwarding table. Okay, so hopefully this is all that was needed. Let's try that same configuration I had before. So we're going to do a show system rollback compare. We'll do 3 to 2. Yeah, so here's what I had before. We'll re-add that. So we're going to do this in 2 commits. The first commit will be set protocols MPLS, trace options, file MPLS, tshoot. The second one will be flag, and then we'll do state and LSP history. Okay, and then we're going to do state. Perfect. Okay, so now after this one, we're going to do. Okay, yeah, no. I know what we're going to do. We're going to apply. Oh no, we're going to commit, and then we're going to get that running so we can see things happen. Oh well, it was already running. Let's do a run. Okay. So yeah, we're good. We're good now. So now we just got to add this configuration here, and we've got 3 minutes to do it. Okay, so not enough time to type badly, so we're just gonna copy it and hit enter. Okay, so we're gonna do this. Let's do a set. Perfect. Okay, and then we'll do a set. Excellent. Okay, so now a top, and then we'll do a edit here. So for some reason, oh, okay, we've got an extra character in our clipboard. All right. Okay, so hopefully we get some helpful messages. We don't have to dig in too deep to see whether it worked or not. So yep, looks like it didn't work, unfortunately. I'll do a show MPLS LSP extensive just because I'm used to looking at that command. So it's gonna recompute soon, but sure enough, it's down, completely failed. Recomputation finished, still no luck. Oh, it's going to recompute in 1 second. But still nothing. I set the recomputation to 4 seconds, so it's going to go a lot faster. Let's look at the RSVP session. So same thing. We don't even have a RSVP session anymore. Really not sure what's going on. So that's going to be the end of the video. Thanks for watching, and I'll see you in the next one.